Hello guys. So far we have discussed about applications of AI. We have discussed about AI, applications of AI. Okay. I have one video for application of AI that I have played in other. Okay. You can check the third one. After applications of AI, we will now discuss about. Let's now discuss about what kind of problems your AI can solve. I guess our last slide was applications of AI. Okay, we need to discuss about what kind of problems AI can solve. Okay, AI can deal with large spectrum of problems. They are mainly called as structured problems, unstructured problems, linear problems, and non-linear problems. So let us have a look at the first one. What is well-structured problem or structured problem? Okay, so this, for example, solving a quadratic equation. Okay, so structured problems AI can solve. For example, calculating a speed of the ball when it reaches a batsman. Tic-tac-toe. So in this case, what we have is, I've represented it over here. You have ordered steps. Either it will take you towards correct result or it will take you to the incorrect result. But what kind of steps you're having? Ordered steps. So this is well-structured problem. In case of unstructured problems, you will have no ordered samples. Your testing samples will not be having any kind of order. And here you are testing for correctness. Okay? These kind of problems are difficult to represent. Okay? Or model them. They may have more than one goal state also. These are unstructured problems. For example, there's a big social gathering. For example, let us say our gathering. And to identify security threat over there. Okay? This is unstructured problem. It is problem in society, right? So it can be addressed using AI. But which kind of problem is this? It is unstructured problem. Playing chess is which kind of problem? It is structured problem. Okay? Predicting how to dispose wet waste safely. It is again unstructured problem. Business expansion, unstructured problem. Okay? So further, they have linear problems. We can solve linear problems using AI. Linear problem means what? Either they will have a solution or they will not at all have a solution. Okay? Problems based on linear equations. Classification problems, for example, whether it belongs to this class or that class. These are linearly separable problems. Okay? And non-linear problems, in this case, relation between input and output is not linear. Okay? These problems need transformations to get better solutions. So you can solve linear problems as well as non-linear problems using AI. I would like to comment one point about structured and not structured problems. In case of structured problems, okay, you will have right answer, right conclusion, okay, when an appropriate algorithm is used. I've already said you, steps are there, you will have right answer if the answer exists or wrong. Okay, well defined steps to measure the accuracy also. To solve the problem also you have well defined step. Okay, this was well structured problem. In case of unstructured problems, we do not yield a particular answer. We can have more than one answer. So we call it as, it is analysis for correctness. No well defined criteria to evaluate the correctness of the output. No ordered steps. Okay, exact goal state is not known. Then we have seen linear problems, the one which are based on linear equations. Okay, classification problem, whether a particular image belong to this class or that class, whether it is melanimous or it is non-melanimous. Non-linear problem is there is no linear relationship between input and output. So we will deal with these kind of problems further. Okay, solving a problem using AI. Okay, how will you solve a problem using AI? First, you need to define a problem precisely. Second, you need to analyze the problem. Third, you need to isolate and represent the task knowledge that is necessary in order to solve that problem. And finally, you need to choose some best problem solving strategy in order to solve that particular problem and apply it. So these are the very 4 steps. Let problem be of any kind. These 4 steps, problem be of any kind meaning, let it be well structured or unstructured. You have to apply these 4 steps. First is define the problem precisely, analyze it. You need task knowledge also, and finally you apply certain technique and solve that particular problem. So here are certain important now things. problem as a state space search. Means what? What do you mean by problem? I'll explain you in simple fashion. What do you mean by problem? It is a question to be solved. Let it be any problem, okay, whose answer you want to find. So first step, what you guys are going to do is define problem precisely. Precisely means what? In short, what we need. So in order to define problem precisely, we need its start state, its goal state, valid state and transitions. You have learned this in talk, theory of computation. Start state, from where it begins. Goal state, where does it end? Valid states, these are the intermediate states. Transitions, that is on applying this particular transition, I go from this state to this state. So using these four things, you can define problem precisely. Second is formal definition of problem. Means this, I represent problem as a state space search. Means I represent the problem formally, in a formal fashion. So it is a process in AI. What is a process in AI? Representing a problem as a state space search. This is a process in AI. Okay, it's a formal definition of problem. It is the way in which you define problem formally. States of instances are considered while with goal of finding a goal state with desired property. Known technique to solve problem are represented as a rule, each defining single state in a space. We will do one thing, we will do these things with the help of example. Right now, just try to remember that we require start state, goal state and intermediate state with valid transitions. Okay, so defining this is called as representing a problem as a state space search. Okay, so we will do this with the help of an example. I have a problem for you guys. It's an interesting problem. Water jug problem. Okay, I have a jug, I have water in it and I have to play with it. Let us see how. This is your problem statement. We are provided with two jugs. One is having capacity to hold 3 gallons of water and the other is having capacity to hold 4 gallons of water. There is no measuring equipment available and the jugs also do not have any kind of markings on them. No markings, okay. So the agent's task here is to fill 4-gallon jug with 2 gallons of water. This is your aim. This is your problem. What you have to do? In 4-gallon jug, you should have 2 gallons of water. By using only these two jugs, no other material, no weighing, no measuring, nothing, no third jug also, okay? So, and your condition is initially both jugs are empty. So this is the problem in front of you. This is problem is written in informal fashion. Now we have to go for writing the problem in a formal fashion. Okay, so how is that? Very simple. Formally, I said you can represent problem formally using state space. Okay, so the state space for this problem can be described as set of ordered integers as x comma y. This is the state space in which I am writing the problem in formal fashion, where x is nothing but the quantity of the water in 4-gallon jug. Okay, so 4-gallon jug has, what is capacity of 4-gallon jug? Either it can have 0 liters or 1 liter or 2 liters or 3 liters or 4 liters of water. So its x can be 0, 1, 2, 3, 4 and y is nothing but quantity of the water in 3-gallon jug. So it was going to be 0, 1, 2, 3. So your start state, we said for state space we require start state and we require end state. So your start status initial condition they have given as both the jugs are empty, so it is 0, 0, and your goal status in the first jug you need 2 liters of water. So starting here you want to reach here. Okay, so this is nothing but representation of state space. Okay, represented in the fashion xy, where x will have 0, 1, 2, 3, 4 and y will have 0, 1, 2, 3. Okay, let's see how to do it. So here comes, it is done with the help of production rules. Okay, this is done with the help of production rules. So production rules, you have come across production rules in talk, theory of computation. What do you mean by production rule? It is having certain left hand side, it is having certain right hand side. Okay, what we have to do is left hand side, I hope you have come across. What you have to do is left hand side you have to match. Okay, and then right hand side will be the action. Left hand side will be the matching part with what you need to match, and right side is going to be the answer part. Okay, so I'll tell you how to do this. So here we have listed total 10 production rules. Your initial state, if it is xy, and if x is less than 4, okay, then you can fill 4 gallon jug completely. So this is one rule. So what is it? Okay, you can fill 4 gallon jug completely. Okay, so if I have xy, my answer can be 4y. If I have xy, my answer can be x3. Why x3? I can fill the second jug with 3 liters of water. Okay, if I have again xy, okay, some water I can take out of 4 gallon jug. So it is x minus d, whatever it can be 1, 2 or 3 or 4. Okay, then some water I am taking out of my second jug. So I am doing y minus d. Okay, then xy. What is this? Empty the 4 gallon jug. So what happens? What is the result of this production? Rule is my first jug becomes empty. Similarly, my second jug becomes empty. Okay, then what here I am done? Pour some water from 3 gallon jug to fill the 4 gallon jug. Okay, so some water is going out from here and it is going here. Some water is coming out from this, okay, to fill this. So its capacity is y. Like some water I am removing out of this. How much I am removing? The one what I need to fill my this jug. Okay. Next is pour all water out of 3 gallon jug to 4 gallon jug. So my 3 gallon jug becomes empty. My 4 gallon jug will get the capacity. And same for vice versa. Okay, so these are the production rules. Okay, this I can say as the left hand side, this is the condition, and this is my right hand side of action. So what is solution to this? Okay, solution is achieved within 7 steps. So let us see, 4 gallon jug, 3 gallon jug, and which production rule has been followed? It has been stated over here. Initially I have 0 gallon in both, so 0 0, that is my initial state. Next what I'll do is, my second jug, we will put 3 gallons water in it. Okay, so which rule I'm using? Rule 2, that I'm filling full water in my 3 gallon jug. Further, I'm transferring this 3 gallon jug water to 4 gallon jug. So which rule I'm using? Rule number 9. So this I'm emptying in this. So what remains over here is 0. Again fill this with 3 gallon jug. So here also I'm having 3, here also I'm having 3. Again I'm using rule number 2 in order to fill this. Further, now this water is put into this jug. Okay, so here I get 4 gallon and here I get 2 gallon. Rule number 7, whatever rules we have designed in previous slide, the same rules we are using over here. Okay, so here remains 4 and here it is 2. Further, I will remove this 4 gallon jug. I will empty it using rule number 5. I will empty this. Okay, so it gets empty, 0 gallons, and over here I have 2 gallons. Finally, I will transfer this 2 gallons of water to this jug. Here I'll have 2 gallons, here I'll have 0 gallons. 0 gallon. So I reach my final step where I wanted 4 gallons water in my 2 gallons of water in my 4 gallon jug. This is the solution that we have achieved by applying different rules. Okay. So for every problem we need to define state space. Okay, as we have done it previously. You can have more than one initial state, one or more initial state, one or more goal state. Okay, set of rules is nothing but your production rules that we have used for previous example, similar fashion. To solve the problem, we need to search the state for proper rules. Now what happens is, where's my previous slide? Like here, I knew what I wanted to do. I know what I wanted to do, but which rule has to be applied? I needed to search it. And in order to search it, I require something. I require to search rules from this production system. And in order to search rule, I require something which I call it as control strategy. So in our further slides, in our next lecture, we are going to study what is control strategy. Thank you for now.